Yeah, let me share my screen. So, okay. So first of all, guys, we will quickly go through the things that we discuss in brief, right? Yesterday. Let me present my screen. So as you can see my screen, right? Uh, Earlier in earlier section, we talk about our YAN and HDFS architecture, right? So before that, I was we in detail talked about our this YAN based architecture, right? How the things happen in YAN. So resource manager is the central resource negotiator in your architecture, right? And the moment, let's say you do any Spark submit job, right? Any command, that resource manager take care of giving the right resources to that your Spark submit command, right? So it talk to the node managers. This is a master worker architecture, right? This is your resource manager, and these are all the node manager. So it will talk to node manager, right? And first of all, it will launch a driver in any one of the VM, right? So that driver is nothing but the application master or driver, right? And then that application master again will see that, okay, how much amount of what exactly I need to do, right? The driver see, okay, I need a 4 executor, and in each executor I need 10 GB of memory, right? 12 cores, and this is the piece of code that I need to run, right? Then this driver would again ask to resource manager, okay, I need this basically executors with this configuration. Then what resource manager do? Since you ask for, let's say, 4 executor, right? It gave you 4 executor to you, and in each executor, whatever the specification you ask, driver will give to you, as long as resource manager with the help of resource manager will give to you, as long as that resource have right storage and compute and core available. So 10 GB of, let's say, memory you ask, right, for each executor. So that's how it give memory to each executor, right? And then your job started processing on this executor. So when your job when it start processing, right, it create the container, right? When I'm saying it asks for 10 GB and 12 GB 10 GB memory and 12 GB core, it nothing but it creating container, and in that container it process your data. So, and then after processing, it respond back to the driver, and then driver return back response to the end user client, right? So that's how the YAN based architecture is, guys, right? We talk in detail in earlier lecture as well. Now, yesterday I introduced you guys another thing, that is this Spark, basically YAN and HDFS, right? So your whatever right side you are seeing over here, the client submit a job, then this is YAN based architecture, right? You have the resource manager, and this resource manager is nothing but whatever resource manager I was showing over here. And then for each let's say resource for this resource manager, right, whenever you are submitting any Spark job on this worker node, what it will do, it will first of all, in any one of the worker node, it will launch application master process. Basically, it will launch first of all drivers application master process, right? And then after application master, it will launch another processes like containers, right? It's the same thing, right? It will first of all launch application master process, and then it will launch container in any one of the location based on availability. So same thing I am showing over here. So this entire right side, right, whatever I have marked with yellow, let's say you submit one job and Spark, your YAN based architecture decide to launch a application master in this specific node, right? Let me highlight it in green, let's say. So for just demo purpose, I show you application master in everywhere, but ideally when you are submitting job, it would be only in one application, in only in one worker node, right? So it will launch application master, and then of course based on the configuration you ask, right? Okay, you need a 4 executor, right? Then it will see the executors. Okay, I have this executor available, this executor, and this executor, and in each executor it will launch a container process of, let's say, 10 GB of memory and 10 GB of core, whatever you have asked, right? So let's say this one it will launch, and again this one it will launch container, right? And this one. So this is how, guys, your uh, entire execution would happen in this container, and then all the response would get back to the your, let me mark, take it a second. All the response, you will launch one container over here, here, and here, and all the responses, that whatever data that container are processing, that response is then getting back to the application master, right? And then of course application master will pass it back to the client and all. So this is how, guys, entire flow happen when you are running, let's say this in yarn based thing, right? But I also told you, right, it's about the distributed data processing. Distributed data processing, right? You have data distributed, and how data is processing, that's what we are talking. But you also have distributed data storage. That's also important, and that come before even processing, right? Of course, you need, before processing you need to store some data. So whenever you are uploading the any file in this cluster, so whatever cluster I am showing, right, this cluster for example, or this is a cluster, small cluster that I have created. Whenever you are uploading any file in your cluster, you have basically HDFS architecture there. Okay, now HDFS is there where when you are doing the things on-prem, right? But if you are uploading file in, let's say, if you are doing the processing in Databricks, right, or Synapse, then the respective architecture is there. What is that respective architecture? Is nothing but the wrapper over HDFS. What's that meaning? In HDFS architecture, you see, in HDFS architecture, our what happened whenever, okay, let's first talk about HDFS architecture, right? When in HDFS architecture, whenever you're uploading any file, right, that file first of all go to the name node. Okay, name node knows what are all the data node I have. Okay, what are all the data node I have, and it know how much capacity it have, right? How much storage, right? And then based on the partition size. So if it is in HDFS, the default partition size is 128 MB. So whatever the file you are uploading, that gets split into block of 128 MB, right? So this one block, this and this, and then it distribute that data and store in different worker node, right? This node, these are also we are calling as a data node in term of HDFS architecture, right? Now once this file gets stored, let's say here, right, this architecture is highly available, so that let's say you have uploaded one file, and that file is split it into two partition, right? The one partition would be available over here, and one is available over here, but at the same time it replicate that data. It even create the replica of, let's say, this file, this block over here, right? So let me mark. So replica of this file, let me take some other color. Replica of this data block over here, and vice versa, right? So it replicate basically this particular data block over here, and again this data block over here. So this is how it replicate that data. What is the important of that replication? It make your data highly available. In case, let's say, if you have uploaded file and this worker node goes down, okay, then still you will be having data available in this worker node. So that's the purpose of basically data node. Now in this and who manage all this information, what are all the blocks available, right, and all, is a name node. I also highlighted passive name node, right? What is the purpose of passive name node? The purpose of it is whenever you are see this name node have all the metadata information, right? Now let's say your name node goes down, then all the information would get lost, right? So we should have that information. So so what name node is doing, is will do. it continuously shares the logs to passive name node. It's a another high availability in term of name node, right? So that if my name node goes down, it should have all the current information of name node, so that if this gets down, let's say, then I still have the passive name node available, and then this passive name node will act as a active name node, and will start distributing data over this worker nodes, right? So guys, whatever uh, eh, whatever this side you are seeing, right? This entire this name node, then name node, passive name node, and then this data node, data block, right? Data block. These are all the component of HDFS architecture, right? Whereas this your yarn, resource manager, node manager, application master, and container, these are all the component of your yarn based architecture, right? So both they work together, but it's like they work in a such way. This part is distributed data processing, and this part is distributed data storage, right? So that's what we talked in yesterday's session in detail. So I just thought to, because this topic is a bit complex, and it needs some more attention. So I just thought to repeat it, right? Now another thing, guys, right? When you are running, let me just erase these things. Now, guys, when you guys are running these things over Synapse, right? Or let's say Azure Databricks, right? There you don't have ADFS. There you have another architecture, which is DBFS architecture. What is that? Current, see, in ADFS architecture, your data node are nothing but they are residing on VMs. Okay. So what are the this worker node are nothing but a VM, right? This worker node also VM, and then this worker node is also this worker node is also the VM, right? So these worker node are nothing but the VMs, right? But in your ADFS architecture, okay, in your HDFS architecture, guys, this worker node will not, the data storage is on top of the S3, right? S3 bucket. And then of course S3 have its own partitions, right? S3 don't have the default partitions of 120 MB, 128 MB, right? Similarly, if you are running the things on Synapse, then in Synapse, your worker node, I'm talking in terms of this thing, right? Only HDFS architecture, right? Your worker node is on top of uh, basically Azure Blob Storage. So that's the only difference, but underlying concept is the same. That okay, you have some data node, right? And you have some node manager. Whereas if you run the things on Databricks and Synapse, this concept still is there, right? They have their own resource manager and application master, and everything is there, right? Basically, Spark is a core of data processing when it comes to the Databricks, right? And Synapse. Spark is there in both places, Synapse and database. But when it comes to the storage, right? Distributed storage. In storage size, guys, you have in, let's say if you are doing things on-prem, then your worker node, basically data storage is top of on VM, right? In VM you attach disk, right? So that disk act as a storage, right? Or data node to your HDFS architecture. But if you are running the same HDFS architecture, but if you are running your Spark job on, let's say, Synapse or Databricks, then your storage is is on top of your S3 or your Azure Blob storage, right? So that's the only difference, guys. So that I just thought to maybe quick cover, so that you should have a better idea on this point. Okay. So okay, we'll talk about the Spark memory and management and other things in some time. Now let's guys focus on some other transformation and action today. Okay. So, and then we yesterday cover multiple Spark transformation and action, right? I showed you the in earlier section, I showed you column-based transformation, row-based, and then how to apply the joins between two different data frame. right? And apart from joins, how we can do the aggregation and all, right? So I am again today also have the same data set. I have employee data set, right? And I am having project data set. So this we talk, right? If you are running any Spark code, right? First of all, you need to use Spark session, right? And Spark session is the entry point, because to run your Spark code, you need a Spark session. And this is just basically factory pattern, builder pattern, sorry. You don't need to get into detail of that, but what it's doing, it's just on a Spark session, you have the builder method and then app name. It is just an app name, that what the name of the program that you wanted to give, right? The session, right? It can be anything. And then get or create, what this method indicate, if Spark session is already available, then give me that Spark session, otherwise create a new for me. Now, once you got the Spark session, you can do spark.read.csv, the path of the file. Header is equal to true, because I want the in my files. If you see, I have headers already available. So I wanted to treat the file with the header, project and sorry, employee and project, right? Headers are already available, right? And infer schema. So basically, when it's read that file, right? How much basically it wanted to know that, okay, if it's reading this, what is the meaning of infer schema? It know, okay, it infer like, okay, this employee ID is integer type, first name is of string type, last name is of string type, that way, right? And date maybe if there, then it's type of date. So that's what it infer the schema, right? Now, again, to recap, what's the things is available in this employee, and because before performing join, you should know what's there in your data, right? So this is just employee data, right? In You have employee ID, first name, last name, in which department this employee is, right? It's joining date, right? Location and location. Then in project data, project CSV, what I have employee ID. So there is a unique between employee and project is the employee ID, right? And then I have the what is the project name in which he tagged, right? Let's say data migration project, data lake migration, and then who is the sorry, who is the his manager name, what is the team size, right? And then performance of that particular individual, and whether this individual is eligible for remote if it is he is eligible, he or she is eligible for remote work, right? So it's a remote eligible, yes or no, right? So guys, let's run this one more. Today we will do some transformation. So now today's let's say task is, one of the tasks is, I need to join, basically join and count how many remote eligible in each location. Okay, so if you see, I have remote eligible, yes or no, right? And here I have locations, New York, Chicago, and other thing, right? I want to know in each location how much the count of employee which are also joined, which should be say, which are also joined based on employee ID, right? And I need the count of for each location how many remote employees are, right? Okay, so I should get ideally output like this. Remote look for, let's say, Francisco. I have two remote eligible employee. So if you, let's say, I will just show you first. Okay, so if I just search for San Francisco, I have 103, right? 109 and 112, right? There are other as well, but I even not have data for 117 and 120 on a project CSV. So these two you can ignore, but 112, 109 and 113. 102, right? This one. Then what is that? 109, right? And last one is 112, right? 112. So if you see, guys, 112 and 109 only have the remote location S, right? Whereas your 103 have the remote location no, right? So that's why its count, remote count is 2, not a 3. So let's do that. Okay, fine. So second. Okay. So yeah, guys. So this was I was just talking, right? So in employee, basically, I think I not share my screen by mistake. So that's what I was talking, right? So these are the basically Spark session. So let me repeat, right? Since I not share my screen. So Spark session is the entry point, right, for your code, and then you are reading these files from here. And after reading, then you tell the header is equal to infer schema equal to 2. That indicate that okay, your file already have the header and infer schema is also equal to 2. Infer schema is equal to 2. That means you wanted to infer based on a type of the data, right? Let's say it's a 103 is there, then you take that employee ID as a integer. That's what called infer schema. So now guys, let run this particular query. Okay. Okay, so our task is to get these things, right? So let me join employee data frame, join project data frame. Okay, based on let me just based on employee ID. Okay, employee ID is unique thing between both, right? So I'm joining two data frame, employee and project based on employee ID. What next? I want data group by location, right? So I will apply, let's say group by location is the basically column name, right? I joined data, then I did the group by location. Post group by, I need guys count, right? So since I need a count, of course, I need to use some aggregate function, right? Because once you group data on that group data, you can apply some aggregation function. So what aggregation function I wanted to apply over here? It's a, let me take this aggregation in next slide. Okay, aggregation. It's a sum sum of sum of which column, guys? So sum I need in a such a way that if remote eligible is yes, then only I wanted to take that count, right? Otherwise, I don't want it to take that count, right? If remote eligible is equal to no, I don't need that count. So sum of, let's say in this case, we need to add guys when condition, right? When, right? When column remote eligible equal to S, okay? When column remote eligible equal to S, then take it as, then I wanted to take that count, okay? But if that that is not there, otherwise, let me take otherwise, okay, otherwise, fine. Otherwise, what I wanted to do, guys, I want to count it as a zero. Let's say if there is a no, if remote eligible equal to no, then I wanted to take that other that particular count as a zero, right? So that I don't sum up that, right? And post that, I think, yeah, it's ending over here our when logic, right? And post that, I just give the alias, right? Some alias. What is alias? Let's say the remote count, the alias that just I wanted to give. Alias is like guys, when you are it's just a labeling particular output column, right? If you wanted to, let's say, label particular output column, this is how you should do. And then finally show. So let me see, guys, just one query. So we take remote eligible. If remote eligible, we are using when condition. If remote eligible equal to yes, then count is 1, right? Then else otherwise you are taking it as a 0, right? And alias we just use for this this purpose, just to label the column. Let's run this, guys. So now we will do some hands-on on this data frame and all, and then then we will cover other topic like Spark memory management and other thing that also equally important. And there are some joins, right? So you see, we got. I already showed you for, let's say, San Francisco. Let me show that once again. I think that time screen was not shared. So for San Francisco, right, it show remote count equal to 2. If you go over here, you see San Francisco is available at 5 places, right? But the column, but row 117 and 120, 117 and 120, I don't have over here, right? So they got anyway excluded because we apply join based on employee ID, right? Now I left with 112, 109 and 103. So 103, you see, it's a it joined, but the remote eligible equal to no. So that's why when we apply this when condition, right? When remote eligible equal to yes, then only count it. And what we are doing on that count, we are summing up it. So that's why, since this is as a no, but our 109 and 112, 109 and 112 are remote eligible equal to yes. So that's why only these two count come, and we got San Francisco equal to remote count equal to 2, right? So that's one of the things just wanted to show, guys, how you should perform join plus group data. On top of group data, you can apply aggregation, of course. That's why you are doing group. And then you also this is a common scenario, right? Adding when clause in your query. So how to add when clause? This is the way, right? You should add when this, then do that, else do this, right? So when and otherwise, if it's like if and else when you do the SQL things, right? And then alias is just labeling the particular output column in some naming convention, right? So this is how you should do, guys. Now, guys, let's move to the another transformation. So what next? Now, guys, let's say I want basically join and find the largest uh, team under each manager. Okay. The task is join and find largest team under each manager. Okay. So let's write query for that, guys. How we should do. Okay. So of course, join, it's saying the joins, right? Then I need to apply join based on our employee ID and these things, right? So let me join employee ID dot join project df, right? I have employee data frame and project data frame. How? On based on my employee ID is unique key between both, right? So I wanted to join based on this employee ID. Now what next? Post join, I want the data to be grouped by manager name, right? The task is find the largest team under each manager, right? So of course I wanted to do some action on top of manager data, right? And that show that, okay, largest team, right? Some aggregation I need to apply, but aggregation I can apply only on group data. So that's why I'm doing group by manager name. Manager name is in my project.csv, right? Then post grouping, what next? Okay, I wanted to see, of course, I will apply now aggregation logic over here, right? Because I need to find largest team. whenever you are on a group data only, you can apply aggregation, right? And here, what aggregation you wanted to apply, right? You want aggregation basically max, basically largest team, right? So largest means max uh, function, right? Where you will apply this max function? So you will apply this max function on team size. You see you have the team size over here, right? And then you just click on show. So let's run this, guys. So this way we can find the largest team under each manager. Okay, this is a mistake. Uh, it's employee ID. It's not employee. When you, the error was talking about that there is no employee's ID. It's auto pop up, right? So we have just employee ID as a column. So that's why it come up. You see, let's say you see now for each manager you are getting largest team size. Let me search. Let's say this name. You see this name, right? For this name, the first name, right? We have 11 and 10, right? But since we need the max team size, right? That's why with our logic only 11 come, right? So this is how you can apply. You can do the that's why only 11 come, right? And we not got the 10th output because we need to find largest, right? From here. So this is how, again, guys, just one of the example how you can group data and post grouping, how you can apply some aggregation logic on top of that, right? So yeah, now guys, let's see couple of further more. I just wanted to show you generally when you are writing code in data frame, right? You most of the time you multiple there are multiple cases, right? But uh, when and otherwise also one of the common thing, right? So let see one more category, one more problem in the same category, right? So our problem statement is on this data set, we want to categorize salary level, right? So we have the salary of employee in employee data frame, employee one, right? Yeah. So these are the salaries, salary column, and these are the salary. Our goal is add a column salary based, salary band based on the salary using when and otherwise. So how to do this, guys, right? So you already have employee data frame, right? In this case, all the data that you need is already available in employee, so you don't need to apply join, right? Now let's go to the, let's see how you can implement these things. So problem statement is we need to add another column, right? So let's do employee data frame dot with column. So whenever the task is to create the new column, the with column is a function that you need to use. Okay. Then salary band is of course that name of that column. Now how, what logic you should on what basis you wanted to populate data in this column, right? Then answer is when employee df dot salary, I think I need to employee data frame dot salary. Okay, when employee df dot salary is greater than, let's say, 80,000, right? Then I wanted to mark that as a high. Okay. Next, post that, guys. What I want, when I need to create a multiple band, right? So let's create another band. When employee df dot salary is less than, sorry, let's do it's auto pop-up. Let's greater than 70,000. Then let call it as a medium, right? Yeah, right. So you guys see, when I move this from, it's completely possible when your data frame is increasing, right, in term of length in your code base, right? You can, it's completely fine to move that into the lower side, right? But make sure that you have dot and other things out there, because it's a function and all. Because when is a function, right? And on top of data frame only you can apply function. So this piece of code, you will return you one data frame, and on that data frame you are applying again this transformation. So that's how it is, right? So when employee df dot salary is greater than, let's say, 70,000, right? Then it's a medium, right? And then I also have one more thing to add. Otherwise, okay, otherwise, what I will give over here, otherwise, I just wanted to label that column as a low, right? Now let's call show method on this particular things, right? Either you can call the show method over here itself, or you can even take this entire piece of code over here, right? You can create another data frame from here, uh, salary band, right? Like this, and then on this salary band, you can call show method. So this is also possible, guys. Now let's run this. So what we are doing now, we are on employee data frame, we are applying on a salary. Basically, we are creating new column there, right? And in that new column, we are adding a logic. When employee data frame dot salary is greater than 80,000, then label it as a high. Label this salary band as a high. Is label that salary band as a medium, or finally label it as a low. So you see, we got new column in our employee data frame. In my employee data frame, I already have from employee ID to location, right? But I now add another column salary band, which talk medium, what band particular employee salary is lies in, right? So this is how, guys, you can achieve this goal of when otherwise things, right? Uh, Now, guys, do one more in few more in this category. Okay, I will do one more in this when and otherwise, and then we'll move to the window-based operation. Window-based operation also one of the key operation when it come to the data processing, right, guys? So now let's come to our second goal. Our second goal is performance rating category. Okay, so of course we need to apply join. Okay, so goal is here, add a rating level column based on a performance score. So there is a performance score, right? You see performance score 4.5, 4.0, 3.8, right? What problem statement is saying? We need to add a rating level column, but after joining, I need to join because you see, I have employee first name and last name. Sorry, employee first name and last name over here, right? So I wanted to get employee, a particular employee rating, right? And since my rating is available in my project.csv, of course I need to join my employee with the project based on employee ID, right? So let's achieve this goal, right? How to get the rating level by joining project and employee, right? Why I'm joining here? Because I don't have basically performance goals. I don't have available over here, right? Performance goal is available over here, so that's why I'm joining, and then we'll take the result. Okay. So now how to do this, guys, right? So first of all, uh, let get join. First of all, let's join this data. Now, guys, see, right till now, I am just writing most of the code in one line, right? But if you are very new to these things, you can even split your entire code into the subsection. I will show you now how to do it, right? Join data frame dot join project data frame, right? How I wanted to join based on employee ID, right? I have the employee ID column over here, right? Now let talk it as a let's call this particular name as a join df. Sorry, join df, right? So I join data. Now what I need to do on that join, right? On this join data frame, what I will do next, I will add another column in this join data frame, that is rating level, right? So join df with column, what is the name of column? Rating level, right? This is a new column I am adding over here. In this new column, what logic, on what basis I wanted to populate that, right? So add just comma. So when let's say performance score is greater than, let's say, some number, I wanted to give that as a excellent. Okay. So when performance score is greater than, so yeah, so one more thing, guys, if you notice, I cannot call the performance score as it is. I need to call that performance score on some data frame, right? So the way we did in earlier session. So this dot performance score, right? Performance score. So when employee data frame, right? Sorry, join data frame, because we joined it, right? So first of all, in first line, we join data frame. On that join data frame, I am adding another column, right? Name of the column is rating level. Now when the join df dot performance score greater than equal to 4.5, let's say. I know there are some in this data set, there are some uh, score with the 4.5. Then I will mark it as a excellent. Okay. Now next thing, because I wanted to apply multiple joins, right? When see it give auto pop-up, I will just use it. So when join df performance score is greater than equal to 4.0, I will label it as good, right? Again, otherwise, so it's a case sensitive, guys, right? If I type O caps, then it will not come. Otherwise, you need improvement. Right? You have data frame entire, yeah. Then you need improvement over here, right? So let me see. Why it's complaining for one more. So I have join df with column I have used. Okay, rating level, and then when join df dot performance score is greater than value is excellent. Otherwise, show, right? Yeah. So guys, let's now run this thing. Let's see how it responds. So I was telling, right, if you wanted to, let's say split something, right, rather than making join and uh, group by and everything into one place, you can also do it's in pieces, right? So that you can understand what are the piece of code did. So see, we have added new column over in this data set. So in this case, guys, I join employee and project data frame, right? That's why I got more columns over here, right? And here I got the another column with the rating level. If performance score is greater than 4.5, it would mark as excellent. Sorry, if performance score is greater than 4.5, then it would mark as excellent. If it is greater than equal to 4.0, it would mark as a good. Otherwise, it would mark as a need improvement. This is how, guys, you can do this when otherwise things, right? When you are doing in it, in this case, you can even split this entire thing into three pieces. Let's say uh, join df and then rating df, right? And on the rating df, then finally you can do show, right? So there are multiple ways you can split your entire program into small chunks so that you can understand the things better, right? So just one heads up. So fine, guys. Now what we will do, we seen a couple of transformation actions, right? We talk with the row level transformation, column level transformation, right? Actions, and then apart from that, we see that how to apply aggregation, group data, and then apply to aggregation on top of that. Uh, Also, when otherwise these are the common thing when it come to the day-to-day activity. I would say when you are working on data engineering project, these are the day-to-day activity that you need to work on, right? So these are the things, right? You mostly work on in your day-to-day activity. Now, guys, what I will do, I will move to the some other operations, right? Windows-based operation. So what are Windows-based operation we will see today? Okay. So purpose of Windows-based operation, let's say you have some data, right? And on in that data, you wanted to apply, let's say you create some window frame out of that data, right? And you apply transformation on the top of that data set itself, right? So that's what we call a window operation. So maybe let me show you practically. That way you can feel it more better, right? So here, guys, I have one file that is I don't need now, let's say project data frame. I just need the employee DF, right? I will mark it as an employee window DF, right? And then it's a employee underscore. Yeah, I think that's the only name. Let me confirm. Employees underscore window, right? CSV. Me infer schema and all this thing I did. Okay, let me just show you first of all what that file contain, guys. So these are Windows operation, right? It typically when you go to the interview or generally in data engineering, you might come into this window-based operations. So I thought maybe it's worth to give you knowledge on those topic as well. Okay, so guys, see, I have this window data frame, right? This particular file, right? Employee windows.csv. What I have over here, employee ID, first name, last name, department, salary, join date, location, and project name. All these columns I have, and that's what you are seeing over here as well, right? Now, let's apply some window-based operationalize, right? So let me show you what exactly I'm trying to say when I'm saying that window-based operation. So our goal is first, okay, to assign. There are common, basically, there are few functions in window-based operation, right? Like you have the, let's say, row number, right? Rank and dense rank. These are the column function, common function that you would typically use when you are doing the window-based operation, right? So now our task is, guys, assign unique row number to each department. Okay. So I have here this data, right? The department, and I have multiple department like uh, IT, right? And then finance, marketing. For each department, I wanted to apply unique row number, right? There can be some cases, right? You wanted to use cases. You wanted to process that data based on some row number assigned to it, right? So in that cases, this might be useful to assign a row number, right? It can be anything. Like, let's say you apply some row number, right? And on that row number, let's say you want, let's say, 5 top row. So that's how, right? Increasing or descending order or ascending order. So those are the common use case behind applying row number to your rows, right? So let's see how you can how we can apply this row number, right? So let's use this df, right, with column. Of course, because I need to assign row number, I will use youth with column. I will give some name to it, like let's say row num. Okay. Now, guys, okay, row num I will use, right? Now, what I will do, guys, next, I will use row number function. Row number, row number function. On what I want to, it's prompting me automatically, but yeah, I will explain, right? So row number function I'm using, right? On what, basically I wanted to apply row number, right? On some window, right? Okay, I think row number over some window, right? Now I need to define that window, right? So what that window is? So that window is, let's say, I want the partition by department. Okay. So let's label this window dot partition by. I have department column over here, right? And my problem statement also talk that assign unique row number to each department, right? So if I want to assign unique row number to each department, right? I know it can be doable with the help of window-based operation, but where I should apply window on, let's say, my, in this case, my partition by department, right? Now, once you apply partition by, let's say, department, okay, then let's do one thing. I will apply not order by uh, salary. So guys, I will explain. Me write these things. Okay, order by salary, and then dot. Let me call finally show. Let me run it. Okay, I will show you that what. what this particular piece of code doing when you're adding row number function, window based operation basically. These are the common interview because with a normal SQL writing this thing without Windows based operation, it's a tough thing. So Windows based things make you think things more simple for you. Windows based operation. Once result come, maybe when I will explain, then that would clear more to you guys. Now, guys, you see, I have partition data. So window is nothing but okay, some piece of let's say data set, right? You have huge data, but you just wanted to split that data based on some column, right? Or some column, right? So how you will be creating that windows partition by that particular column, right? In my case, it's a department column. Okay, I partition that data. Now on that partition window, what I'm doing, I'm applying order by salary. So you see, let's do one thing. Let's do one thing, order by, okay, fine. Let's go with this only. Okay, order by salary. So you see the list salary, I am getting at a top number. I wanted to, let's say my use case talking about, I need list salary from each department. And if it is list one, give that label as a one. Second list salary, give label that as a two. Third list salary, give that label as a three, right? Don't you think, right? If let's say some query, some programmer ask you, okay, give me list salary from three lists salary from each department, right? So you have now entire data available. You can just pick up three salary from employee department, from finance department, three list salary, then three list salary from your HR department, and three list salary from your IT department. If let's say interviewer ask you, okay, I need the max salary, right? How you should do? Then simply, guys, you apply here. Yes, order by whatever DESC salary. I wanted to apply DEC function over here. Yeah, descending, and the column name should be inside. So that's why it was showing error. Right? Yeah. So it's a case sensitive, sensitive first of all, guys, and you need to apply descending. Salary is a descending function, take a column name, right? That's why we give the column name. And now if I run this, I should get on each department. That is my window. Here my window is department, right? And on each department, I apply some further transformation. Okay, on each window operation, uh, which is partition by department. Okay, I apply descending salary I need, right? So it should give me, of course, top salary at the first. So if interviewer asks, okay, give me from each department three top salary, right? So this is how then you should write, right? For example, in finance, you see earlier we were having least salary. Now from the finance, these are the top salary. From HR, these are the top salary, top three salary, and from IT, these are the top three salary. So that's the importance of Windows function, guys. What you do, it on of course window you do on window you of course you apply window on some column, right? And how you create that window, This is the syntax to create the window. You create the window on top of some, let's say, window partition by and some column name. Once you apply that window, on that window, you can then further you do your transformation, whatever you want, right? Then next you do your further transformation on that window, right? Now let's see, guys. Here now, we are trying to get just row number, right? Now let's see some other window-based operations. That is, now we will go to the rank function. Okay. So let me. So our problem statement is this one: assign the rank within each department based on a salary, right? Based on salary, I want you to assign the rank within each department. How to do this, guys, right? Let's do this employee data frame. Let employee windows. Then I will be create another function over here with column. Rank is the name of the column. Okay. Because I need to assign the rank, right? Based on a salary, I am creating rank function. How, on what basis I should create the rank, right? Let me call a rank function, rank over window, right? Now, see, in earlier case, I gave the row number over window. Here I am calling rank over the window. So whenever you are creating, so these functions get called on top of window only, right? Rank over the window or row number over window. Now, what is that window you wanted to define? How you wanted to define that window? Again, windows dot partition by, my column name is, in this case, what's my column name? Department, because I need within each department, right? Rank within each department based on salary. So let me take a department, partition by department, right? Now, post partition, right? Post partition, we what we want, right? We want basically dot order by which column? Salary. Order by salary. Okay. Let me take this over here. Right. So first of all, I create a new column rank, right? How I wanted to generate data for this rank, I will use the rank function. Rank is a window-based function. The moment you use this function always you need to use over some window. This is what the window you create, window partition by department. Okay. And then order by salary, ascending order in this case, right? Not a descending, but if you want, you can do that one as well. Now, guys, uh, let me, or for simplicity, let's do these things. TESC column name. Yeah, so that would be more better to understand, right? And then let's do, guys, dot show. Guys, one thing to note, when you are writing show command, it just give you 20 column by default, right? Your data frame might contain 100 columns, sorry, 100 rows. When you are showing, when you are calling show command, by default, it will give you just 20 rows. But if you need all the row, this is how you should do, right? Now let's run this thing, right, guys. It should ideally assign a rank to rank based on a salary within each department. And now we apply descending order. So max salary will get first rank. Post these, guys, we have one more function, window-based function. Okay, let's focus here. Okay. See, you see, we didn't got the rank. Why? Because we apply transformation, but we not create any output out of it, right? So that's why, and we just call in earlier data frame only we call show. That's why we don't not got output. So let's say output is a data frame. Let's say I am creating, and let's me do this way. Now it should show us output. So output of this will come to here in this variable. This is also is of type data frame only. Whenever you are applying transformation on data frame, the resultant output is of type data frame only, guys. Same for IDD as well, right? In earlier session we called IDD programming. You hardly do because it's a low level API. You will not get chance to work on IDD. But all this your code when you run on a Spark cluster, it boils down to the IDD code itself, and Spark engine take care of that. Okay. Now see, you apply rank function. We create the rank column. Okay. And in the rank for each department, now we have max salary, that is rank 1. Second max, rank 2. Let's see some cases, guys. Okay, count. For example, okay, you see, for let's talk about the IT department, right? First max salary, you got rank 1. Second max salary, you got rank 2. Third max salary, you got third max and almost see, these three are the same salary, but he give it the same 222 number, right? You see, first two are right? Because 99 and 98, of course, this is first one and this is second one. This is right. And here you got, though it's a in next, though it's have the same basically salary range, right? These three are same, but it still give the second number, which in some cases, of course, it is right as well, right? Because they are anyway ranking at second number only. But there might be cases, okay, that you basically the same rank. Let's say if there is a rank same, but you don't want any gap over there, right? So I will show you with the help of next command, right? You will see the differences over here, right? Rather than me telling anything now, but here you just understand now. We got the second rank for both these things, right? Second rank for this one, second rank for this one, and second rank for this one. This one. I'm not saying that it's wrong, but yeah, in some cases this can be useful, right? Because you have the all these three coming into the second base category. But you might need some more enhancement in data, right? So how to do that? Let For that we will see another window-based function, and then maybe you will get more clear with what that function is. Okay, which is dense rank. It's the same rank, but no gaps in ranking. Okay, let me quickly create write the things for it. Okay, and then with column, the name of the column I wanted to give as a dense rank, right? Of course, on what basis I wanted to generate that? There is a dense rank function over window, right? Dense rank is the function name. On what we will apply this window-based function, window-based function, these methods on top of dense rank, row, all these function I will call based on some window, right? So what that window partition by, let's say, column name department, right? Now what next? I wanted to partition by department, right? And then what I will do? Then I will use order by DESC colon salary, right? Dot show. So in this case, now I directly applying show method on top of this. So let's see how, guys, how this run. Okay, IT, okay, 1990. I think, though I not call here employee dot show and count, but what all data I wanted to show you guys. So of course, here you see Dane's rank function you apply. He- Here also you got any question, guys? Any from anyone? Okay, no. So see, you see, right? You have salary, of course, in descending wise, right? And you apply the rank for each salary. Here max salary 1, second max 2, third max 3. Now let's come to the main thing, right? And it would do, right? The in descending, it would give the ranking to each one. Now our main concern is, you see over here. See, for first one it give 1, okay. Second one it give 2, right? And basically, if you see in this case, it not what's the purpose of dense rank, right? If you want no gap, right? Earlier cases may no gap in term of, let's say, ranking, right? Then in these cases you can use this sort of function which is dense rank. But if you needs, let's say, some gaps in term of ranking, then this dense rank is the function that you need to go through, use basically. So that's the main difference, guys. Nothing else. Okay. So here, let me do one thing. Employee window. Okay, and 112. Let me use both thing. Show I'm running both the thing at the same place. Okay, I got 1, 2, 2, 2. Okay, I think I need to correct some my data to show you this point. Uh, Here you see, in case of dense rank, let's say 1, 2, 2, 2 number I got, right? And in case of 1, 2 and 2, 2, 2, right? 1. Okay, here I need to apply descending order by the salary descending salary. Okay, let me run it. Maybe some data correction I would need. I will maybe not spend time there. Maybe I can explain that thing later as well, because let me run it once. So basically, guys, window function, right? You understand that window you will always apply on some a specific partition, right? And that partition can be data frame, any column in your basically CSV file, right? Or in your data set. And that on that window, then you will further do some other order by mechanism, or right further transfer. Basically, you can do order by or ascending, descending, and any other operation that on window that you wanted to perform, you can do on top of that. So let me see if there is issue in this data. So 1, 2, 2, 2 I got over here. Okay. And 1. Okay. I think there is some issue in this data set. Okay. It's not working good for, let's say, your this thing. It's working better for rank function. Okay, the way it's expected. I need to correct that data, guys. Maybe in upcoming tomorrow's next session, I will cover this dense rank as well. But you understand the rank with prospective rank, right? uh, for what we learn from here, for each when you are applying rank function, right? If interviewer asks that, okay, for each function you for each particular row you wanted to apply some ranking, right? So this is how, guys, you can apply rank, right? So for first salary, highest salary in IT, you give rank as a 1. Second highest salary, you give rank as a 2. Third highest salary, also you give rank as a 2 only. Okay. Uh, Second, I think. Okay, I got uh, okay 5 number. Uh, okay, 1, 2, 2, 2, 5. Okay, sorry guys. I think no issue in data set. We just missed one thing. Okay, let me run. If I run both the things at one place, you will understand that difference. So see, no gaps in ranking. Okay, and rank talk about these things, but with now what's the meaning of that? I will show you. We just miss some data, right? So first result is dense rank, guys. Let me go to the dense rank, right? This is first output. So you see uh, for IT, highest salary is this one, it come. Second highest I got this one. Third highest also I got 2, and fourth highest also I got 2. That is completely right. But post that, see guys, I got the 3, right? With the help of dense rank. So one, it not skipped any ranking. So of course, post 2, 3 should come, right? Post 2, 3 should come. So it's completely right, because department is IT only, and I got the third max salary, this one, right? Now let's see same for ranking. You see, first IT highest, second IT second highest salary, third highest salary also got. So though all these three are having same salary, it got 2, and above also for all the same one we got the 2 only, right? Or all are the same, but we got a 2. But in this case, the next highest, right? I got a 3. But whereas if you see here, for next highest, I got a 5, right? So it's keep that ranking. Post 1, 2, 3 should come, right? Not a fifth, right? So that's the only difference between rank and dense rank, right? So below one is, guys, this ranking, and above one is dense rank. right? So mostly you will use dense rank, but yes, there might be cases that you need to use rank as well based on your requirement. So right, guys. So these are the earlier I thought some issue with data set, but it's not. We just miss this below line, right? So that's how it is. Fine. Now we cover rank and dense rank. Now, guys, some important topic also I wanted to cover now. Let me go to my this diagram. Let me show you my another screen. So guys, I hope you can see my screen, right? So let's talk about some joins. Okay, till now we earlier you remember we talk about left join, right join, inner join, right, and then left semi join, right? All these join we talk. These are typical join which are also available in SQL, right? Whenever you are doing the SQL based operation, these are the common thing that you do, right? Equi join, left join, right join. But there are some other, from the Spark perspective, there are some important joins. First is broadcast. Second one is shuffle sort merge join. Let's talk about that. Whenever guys you are writing some piece of code, right? You are joining two data frame, and your one of the data frame is small enough. Okay, let's say you have two data frame and your one of the data frame is small enough. So let me show you that practically. Let me present my ID once again. Okay, so guys, let's say, let imagine this is a piece of let's say we have two data frame. The employee data frame, of course, it have very huge employee data, right? So it's a large data frame, right? And project, of course, compared to employee, there could be less project. So this is a small data frame, right? Now, guys, when you join these two data frame, right? Let's say employee data frame dot join project data frame. Okay, project data frame. How? On, let's say, employee ID. Okay, and let's say you want to do simple show. When you apply a join between your large data frame and small data frame, what happen internally, guys? What Spark do? What Spark handle these things? Let me present my diagram once again now. Okay. So when you are joining your small data frame with your large data frame, right? Your big data frame, whatever. So your Spark would move that small data frame in each executors. Okay. So that there won't be more shuffle. There won't be any shuffle, right? Imagine, guys, if I have this two data frame and I wanted to join based on, let's say, some key. Okay. And without broadcast, what happen? What will happen? Let me show you with the help of some example. Let's say you have one executor. Guys, these executors are nothing but the one that I explained earlier, right? These are all your executors, right? This executor, let me take a marker. So these executor are nothing but this executor, right? So now when, let's say, you are applying some you join between two data frame, one is small and one is large. Okay. So let's say I have this executor, or the worker, of course, executor is on a worker node. So, and then I have another executor, right? And in this executor, let's say I have this piece of data frame. Okay. Let me take a data frame with some. other thing. Okay. So let's say I have this piece of data frame. Here I have, let's say, my big data frame, right? And here I have, let's say, my small data frame. Guys, without broadcast, okay, we know that. Okay, what is the purpose of a broadcast join? What it's saying, it's transfer your small data frame across all executors. Okay, so that it can perform join. Of course, you are joining based on some unique key, right? You need that data to be at one places. In earlier section, I showed you, right? If you are joining, your both data frame which contain that joining key should be on single executors. When I was explaining this thing to you, and when you are applying any joins, right? At the time of joining, at the time of joining, let's say you are applying you are joining one table with another table. Its matching key should be at a one place, right? Now, in this case, what happened, guys? You have small and you have big data frame. Now, let's say if you wanted to join, right? What Spark will do, since it need to join, it need to move all data from big data frame to small data frame, right? So here, right? And it also need to move some of the key from small over here, right? But don't you think, guys? See, I don't have problem in just moving this small data frame from here to here because it's a small data. But just for your some some of the joins, okay, you are moving your entire big data frame from here to here, right? When I'm saying data frame, it's a join basically keys from here to here. So maybe some you have move, let's say, big amount of keys from here, and now the remaining keys are over here, right? But don't you think that you shuffled very huge data across the executor, and shuffle always make your cluster performance downgrade, right? So what is the best way? If one data frame is small enough, right? Small enough to fit into the executor memory, right? Then you can broadcast, Spark can broadcast that particular small data frame across all executor memory so that there won't be any shuffle. So no shuffle would happen on this Spark, on this executor memory itself. This data frame would go, and then you can do the joining between these two data frame based on some unique key. In this case, guys, you see no shuffle happen because data is big data frame is already partitioned based on some partitioning key, right? And it's already stored in different executor. Now your small data frame got shifted in executor memory, and that's how then you are applying join, and this would reduce your data shuffling. So that's one of the main join, right, broadcast, which help you to reduce shuffling data. Now question, guys, how to perform that join? Let me show you practically. If let's say you wanted to do some broadcast joining, okay, let me use here itself. Okay, I will directly add this piece of code, which I think will take less time to explain to you guys. It's a simple, very simple thing, right? As you see my screen, these things are anyway known to us, right? We create the Spark session and all. When you are applying broadcast join, right? In broadcast join, you need to give this Spark configuration setup, right? What is the value of broadcast? Means how small your data frame should be so that we can move, Spark can move that to, let's say, executor memory. This is a value I have give, okay, in term of bytes, but it's configurable. You can give the 1 MB, 10 MB, whatever, right? But I believe default value is 10 MB. But it's configurable. How my data frame should be small enough so that I should be able to move that small data frame across all executors, right? Then what I will do, this is my, let's say, to data frame, right? And to apply the broadcast join, I just need to use broadcast and project data frame, for example. So in this case, let's the way we talk, right? Our project data frame is small one, right? Our project data frame is, and employee data frame is large one, right? So that's why I broadcast my project data frame, which is small enough, across all executor. So when you are running and how it's simple join I am applying, I just call one function, that is broadcast, and this is on what which ID I wanted to apply, basically join, because I need to perform join, right? So on which ID, it's employee ID, and how the inner is basically which type of join, it's an inner join, of course, right? So this is how, guys, you will apply broadcast join when it comes to the coding part. And then of course you will run and it will show. Functionally, if you run this piece of code, it is nothing, right? It's it's just equi-join, right? You are doing some join between two data frame based on some unique key. But internally, how things happen, your when your Spark engine identify that small data frame, okay, and it see, okay, one data frame is small enough, okay, small enough to broadcast, then it will move that small data frame across all different executor wherein your big data frame reside. So this is output. So that's a simple thing, right? We are just joining based on some ID, but let me go to the this part, right? So your small data frame, in this case, you are moving this small data frame across all the executors basically, right? And these executors are nothing but the same guys which I have explained in earlier sessions, right? These are executor, right? Whenever you are doing basically loading any file, that file gets splitted into the partitions across the executors. So executor 1, 2, 3, 4, right? So in this case, let's say your employee data frame, right? Your employee data frame, let's say having the 4 partitions, and that's a big data frame. It would get split into this one partition over here, one over here, one over here, and one over here. Now what happened when you have the small data frame, right? That is project. That project data frame will get transferred to all these executors, okay? And then joins happen among them. And this would reduce your shuffle, and that's how you are getting more output from your better output and better management of your cluster. So that's the one thing about, guys, broadcast join. Now let's talk shuffle sort merge join. This is common interview question, guys, right? If you have one big data frame and one small data frame, which type of join you should apply? So answer is broadcast join. And you need to explain that detail about how the things happen at executor level and all, right? In earlier section, we cover these things, executors and other things. But idea is it broadcast your small data frame across all the different executor, wherein your big data frame lies, okay? Wherein your big data frame is available, there it hosts that small data frame, okay? It move that small data frame. Now, guys, shuffle sort merge join. What is the purpose of this shuffle sort merge join? Okay. Okay, this is also one of the common interview question. You have one small data frame and one big data frame, we know broadcast join. But what if both the data frame are big enough? And the big enough not to accommodate in executor memory, right? So I have this 4 executor, I have 2 big data frame, right? Employee data frame, and let's for this case, imagine that my project data frame is also huge, just for this use case, right? And my employee data frame is also huge. Then how you should perform the joins, right? Because of course, if you can perform join based on some unique key and all, right? That's no brainer, but it would shuffle data, right? So what shuffle sort merge join do? Okay, so just read about few things. Okay, in this case, what I am doing, join 2 big files, okay, of 512 MB based on unique ID, right? That's what my task is. So I first I loaded employee data frame, then I loaded project data frame, and I am joining that based on some employee ID as a unique key. Now what happened, guys? As I explained earlier, whenever you are uploading, when let's say your files is there in executors, right? Let's say your files are available in your HDFS cluster. The moment you write this piece of code, right? And when I'm saying your file is uploaded into your HDFS cluster with the default size of, let's say, 128 MB or whatever the configuration is there, right? So now I think, yeah, so 128, let me just do some calculation. 128 into 4, I think. 128 into 4 equal to 515, right. So I told, right, I have 512 MB of file, and my default partition size is 128 MB in HDFS cluster when I am uploading file, right? Now, when you are running this piece of line, what happened, guys? Spark would read that file and create a partition. Why it create a 4 partition? Because default partition size is 128 MB. So that's why in each executor, it create 128, 128, 128, and 128. Okay. When you are running the second line, then again it would create 128 MB of partition, 128, 128, and 128, right? So you got that data in memory to now join. Now, when you are applying the third, when you are executing the action, right? This is action. In this action, you are doing also doing wide transformation, right? That is join. What happened, guys? Let's say you have one employee data frame, right? Here 101 is a unique key, right? And 103 is a key, and 103 is 102 is a key available. For example, in this data frame, I have these keys available: 101, 104, 103, and 102. And now imagine that whatever the project data frame I have, here I don't have any one of the unique key over here. So let me just for time being create this project data frame. Okay. And let me just give some any random number. Okay. Guys, how I can join two data frame if they don't have any unique key, right? You just ignore this first name and last name for now, because anyway I am joining based on unique employee ID. But if there is no matching key, it cannot perform join. So what it need to do? It need to shuffle data. What it will do? It will move this project data frame from here to here. So all this data you see, right? It will move this data from here to, let's say, here it move. Let me not got it. Okay. Let's imagine that it shuffle data in Spark cluster. Now when it move data from this data frame to this, because I have it's see that, okay, I have some unique keys over here, right? And that's why it shuffle 101, 103, and 102. Similarly, the 104 is not might be useful in some other place, right? So again shuffle would happen, and this 104 would come in some other place. For example, here for the let's say, let me give this as a same color what we have over here. What is the color, guys? Yeah. So it would also shuffle this data set as as well, right? So for simplicity, I am just giving one row, guys, but there can be millions of row, right, which get shuffled, right? So now, guys, you got, now ignore for this thing, this particular one for now, because when you are performing join, you need write data to join, right? So you see now I got 101, 103, and 102, right? now only I can join, right? But this happened, the shuffle from one executor to another executor. I shuffle always downgrade the basically performance of your cluster, right? So if data frame are big enough, there is no other option that you need to shuffle. But what shuffle sort merge join do? Okay, uh, the in shuffle sort, of course, it would shuffle data, but it also sort this data. See, you need to apply join, right? So of course, when you are applying join, if data is in already sorted nature, then it's easy to apply join over there. So what it do, it sort your data. What shuffle sort might join do, it sort your data, right? Okay, it sort your data, and then it apply then join based on two key. Okay, it would match 101 with this 101, right? This 102 with this 102, and likewise for 3 as well. Imagine guys, if it don't do shuffle, it might be possible your 101 at a first row, and if it's a huge file, right, your 101 on a right side on, let's say, last row, right? Then in that case, it traveling through data set, right, and searching, that make things more complicated. Shuffle anyway we are doing, but on top of that, if it's need to travel to see particular where is my particular row to which I need to join to, then it would incur more cost to your cluster, right? So that's why if you shuffle your sort your data, then joining merging would make more easier. So that's what guys, shuffle sort merge join come into the picture when you join two data frame, both are huge enough, okay, to not occupy so huge enough in the sense that they cannot come into the executor memory, right? And in that case, then you do shuffle sort merge join. In shuffle sort merge join, your files get splitted. So in this case, I have 2 big file of 512 MB, right? So why 4 partition got created? Because 128 default partition size, right? So it create the 4 partition, and for project data frame also it create the 4 partition. Now they are joining based on some unique key, which is this one, right? Employee ID, inner join. And after applying this inner join, then the moment you apply inner join, right, it shuffle data the way I showed you, right? It shuffle data from one executor to another executor, which will cost more, which will incur more cost to the cluster, right? So shuffle we cannot avoid, but with the help of sorting, we can of course reduce our processing time, and that's what a shuffle sort merge join, guys. Okay, that's another join I wanted to take, guys. These are the common people ask in interview question, right? People mostly know the concept behind the broadcast join. Okay, if one data frame is small and one is large, of course it would help in broadcasting. But shuffle sort, but if the question come, if both the data frame are huge, then you will be using shuffle sort merge join. Okay. Now, few more thing, guys, I want to cover today. Spark memory management as well. Okay. Uh, so guys, whenever you are running one piece of, uh, I told you right in earlier this diagram I showed you, whenever you are running piece of code, let's say this piece of code you wanted to run, okay, this one, it execute into the it execute into the this container, right? Container is a JVM process I talked, and basically it's a executor memory we call. In the Spark terminology, we call it a executor memory. Here we are running your piece of code, right? When you are saying that I need, if you see over here, I told that I need executor memory of 10 GB and 12 executors, right? So of course, how much memory your program get? 10 GB, right? And your program would execute on that 10 GB of memory. This program, right? Let me take marker. Your this program would execute on your this program required 10 GB of memory in each executors here, here, right here. That's what we are saying. I need 10 GB of memory and 12 cores. 10 GB of memory and 12 cores. And then your program would run over here in this executor memory. Now let get into this executor memory. What this executor memory further divides. Okay. How Spark do memory management for this executor memory. So imagine guys, in my case, for example, I am running one piece of code, the same piece of code, for example, and I told that I need 8 GB of executor memory and 12 cores. Okay. Now 8 GB of executor memory, guys, okay, will divide into this way. You ask for your program, I need executor memory and this work. Imagine this one worker node is nothing but whatever the node you are seeing over here, right? One worker node. And on top of that, you have one, this executor is running. This is what this executor memory we are talking about. You have one VM, and in that, this container, whatever you have launched, right? This container. Now let's see. Sorry, not edit. Okay, let me take a container. So this container is nothing. Now I am talking in detail about this container. What's happening in this container, right? So here I showed you just one container, but how the memory management happen in this container, let's see now. So what happened, guys? You ask 8 GB of memory, right? That 8 GB of memory is divided into three sections: reserve memory, Spark pool memory, and user memory. Reserve memory used by Spark engine. That Spark need that memory, you cannot use it. Spark engine, right? I told that catalyst optimizer and that it create the logical plan, physical plan. For all this, it needs some memory, right? So, and even for some, whenever it's doing some transformation and other thing, right? It need that reserve memory for Spark. So you will not get this memory. It's reserved by Spark. Plus, so how much you left, right? If you talk about, you ask 8 GB of memory, right? Out of that, if you remove 3000, sorry, 300 MB, you left with 7700 MB of memory. In this 7700 MB of memory, you have further split Spark memory and user memory. So Spark memory pool uh, and user memory, right? They work in, guys, 60-40 ratio, right? So 60% will allocate to your Spark memory and 40% will allocate to your user memory, right? So that way, your Spark memory got 4620 if we talk about the 60% of 7700, and 40% of 7700 is 3080, right? Now, this Spark spool memory, okay, we will use for our transformation, basically all the transformation, right? And the caching operation that you do, data frame caching. For all your transformation and caching, you will use this Spark memory pool. And for user, the purpose of user memory, guys, is like whenever I showed you, right? IDD lineage, right? IDD operations. When you are creating the uh, transformation, it create the DAG of IDD, right? So that direct asali graph of IDD, right? So for that, it needs some memory, right, to keep a track of that IDD, right? So it use this user memory use for this IDD lineage purpose, right? How IDD is getting created, because ultimately, whenever, even if you are running data frame, it's boiled down to the IDD, right? So you might ask that these things that even if, let's say, my data frame also converted into converting into the IDD, why I am not using this one? So no, Spark, the way Spark use only for IDD lineage and IDD operations plus user defined function. I will cover the user defined function in upcoming section. For that purpose only, it use user memory, right? So even if data frame compiled down to the IDD, but still it will not use user memory unless you use IDD based operation. Guys, mostly we are writing code in data frame, right? But you can also write the code in IDD as well. I will show maybe in upcoming section how to use that IDD, right, operation, right? But you will never get chance to work on IDD. It's a low level API, right? So any IDD operation, IDD lineage and all these things, for that it use user memory. Now, guys, this transformation and caching, right? For that you use this Spark memory. uh, what is the caching, guys? If someone, some of you might not know, see, caching is, if you go to my this again this piece of code, right, and just wanted to cache any data, right? In earlier session I told you what is the caching, but let's say, so not count dot cache, right? So now, guys, this data is in Spark memory. You don't need to, let's say, I am currently just reading data from the file, right? But I want that data should be always in my memory. Then I can cache that data. So this way, guys, my caching, for my caching and transformation, I use Spark memory pool. Now, guys, this Spark memory pool further divided into the storage memory and executor memory. All your right? So it give 0.5% to the storage memory and 0.5% to the executor memory. For example, whenever I am saying that, okay, I want to run my, here if you see, I gave 12, here I am saying that 12 executors, right? I want in, basically, I'm asking the 12 executor, right? So, so let's do one thing. 1, 2, 3, 4, 4 core. Let's simplify this with the 4 core only. Otherwise, I need to add some more diagram there. So 4 cores, right? So what happened, guys? In your Spark memory pool, right? You split further it into the storage memory and executor memory of 50% and 50%. Your Spark engine, all the transformation and all these things, it will do in this executor memory, and all the storage like caching, right? Oh, just I showed you caching, right? All this storage would happen at a storage memory. It might be possible if your storage is not utilized, your executor memory can get more space, but of course then it would reduce, let's say, here 1000, and let's say here you make whatever, right? 4620 minus 4620 minus 1000. Let me do that. Right. So 36, yeah, 3620, right? It's possible, right? If you don't have anything in cache, then your executor, if your Spark need more memory to process your data, then that happen internally, right? And now when you are executing, what happened, basically, since you ask the 4 cores, right? 4 cores, all these 4 cores will get equal amount of memory. So let me just undo these things, right? Earlier I told you, right? Let go with the 50-50%. Otherwise, this calculation also I need to change. So whenever you are running your piece of code, right? That piece of code, I mentioned that I need a 4 core, right? So each core will get then how much of memory? That is 577. So 577 MB of memory, I will, my each core would get, right, to process it data. So core is nothing but the thread which is running on your data, basically your particular data or data frame, right? So this is how, guys, this entire things get splitted. I will again repeat. In Spark memory management, you have worker node, right? And in worker node, this worker nodes, right? You have one container. Now let's see what things are there in this container. This entire thing is just this container only, whatever we are talking, right? This entire thing is container only. The details about the container. In your container, you have some reserve memory, Spark memory pool, and user memory. Spark memory pool you use for storage and executor. So for your data processing and data storage, data frame processing and data frame storage, whatever your data frame operation are doing, you are doing will get transform, right? And then storage would happen into this section, right? And then you have the user memory as well, guys. User memory you mostly will use for IDD and other stuffs. Now, next thing is IDD lineage and other thing, right? Now, I told that Spark memory further divided into the storage and executors of 50%, right? So in this case, now since your executor have memory of uh, 20 10, right? If you divide and you ask how many cores you ask 4 cores, right? So if you divide this executor memory into 4 cores, each core you will get 577 memory, 577 MB of memory to process data. So that's how, guys, your entire basically Spark handle that your entire memory, right? When it's come to the Spark transformation and action, right, guys? So that's what I just wanted to cover the detail of this container and how the things, how the Spark memory is converted into the storage and executor, right? And for if we talk about the executor part, in executor also, then further it's split into the number based on your number of core, whatever the memory that you have asked, right? You ask 8 GB of memory, but out of that your executor only got this much of memory. 2310, and that also then for each since you ask for 4 core, right? You just divide that 2010 divided by 4, so that way your each core will get 577 MB of memory. Of course, this thing can get varies if let's say you don't have any storing or any caching operation, your this executor memory would get increased, right? It may be possible it completely goes down to 0 if you are not storing anything, and you would occupy entire 4620 over here, 4620 over here, right? But then further this core, each core will get 4620 divided by 4, whatever, right? That number of memory you will get for each core, right? So this is how, guys, internally memory get allocated to core. So that's all I wanted to cover, guys. These are some detailed section about the Spark and other. So any question, guys? Yep. If no question, we can conclude today's session, and we'll cover you in upcoming session, guys, wherein we will now focus more on AWS side, right? We'll use some glue and other things, and also other topic we need to cover. So we'll see you guys later. Thank you very much. Thanks. Stop share.